In this session, we are going to review formulas from electricity chapter of CBSE 10th grade. Electric current. If charge Q pass through a conductor in time t, the current I is given by Q by T, where I is the electric current in amperes, Q is electric charge in coulombs, and time t in second. So ampere is equal to coulomb per second. If there are n numbers of electrons, then the total charge will be equal to n multiplied by charge on one electron. That means Q is equal to Ne, where Q is electric charge in coulombs, n is the number of electrons passing through a cross section of a conductor, and E is the electron charge in coulombs, which is equal to 1.6 into 10 raised to power minus 19 coulomb. This is the smallest unit of charge. A charge can be found in multiple of this one electron. And now if you want to know how many electrons in 1 coulomb, then you have to use the same formula, n is equal to Q by E. Put the value of Q is 1 coulomb and divide by charge on 1 electron, which is 1.6 into 10 raised to power minus 19 coulomb, and you will get 1 coulomb is equal to charge on 6.25 into 10 raised to power 18 electrons. If W is work done to move charge Q between 2 points A and B, then the potential difference between 2 points A and B is given by V. V is equal to W by Q. Here the W is work done in joules to move the charge, and Q is electronic charge in coulombs. So volt is equal to joules per coulomb, or you can write down V equal to J by C in symbolic form. As per Ohm's law, if current I flow through a resistor R, then the potential difference V across that resistor is given by V equal to IR, where V is a potential difference in volts, I is the electric current in ampere, and R is the electric resistance in ohms for that conductor. So volt is equal to ampere ohm. If a 1 ampere current is flow through a resistor of 1 ohm, the potential difference across that resistor is equal to 1 volt. Electric resistance and resistivity. Resistance is given by rho multiplied by L divided by A. Here the R is the electric resistance in ohms, and rho is the electric resistivity of material, and unit of measure of it is ohm meter. Electric resistivity is the property of material, and it doesn't depend on the dimensions of the conductor. L is the length of the conductor in meters, and A is a cross-sectional area of conductor in meter square. So A can be written as pi r square if conductor is cylindrical. R is radius of conductor in meters. Now resistivity rho can be given by R into A divided by L. Although here in formula you see the area A and the length L of the conductor, but the resistivity, remember, doesn't depend on these parameters. It's only depend on material. If resistors are put in series in a circuit, as diagram shows, the same current I flow through all the resistors. Here the current I can be given by the ratio of potential difference divided by resistance. This potential difference can be across all three resistors combinedly, which is V, and R is the equivalent resistance of R1, R2 and R3s. Or it can be also given by individual resistors. So here, for example, the V1 is a potential difference across resistance R1. So V1 by R1 is also equal to the current flowing through this circuit. Similarly, it's equal to V2 by R2 and V3 by R3. The total potential drop across these resistors is equal to the sum of V1, V2 and V3, and it's equal to the potential difference between battery terminals. Now if you put the values of V in form of I and R, we will get a equivalent resistance of these three resistors. So here if three resistors R1, R2 and R3 are in series, equivalent resistance R is equal to R1 plus R2 plus R3. If there are n resistors of same resistance R in series, then equivalent resistance Re is given by Re equal to NR. When resistors are in parallel, potential difference across all the resistors are same as V. The value of V can be given by any of I and R relation for any of the resistor. So V is equal to IR, where I is the current in the circuit here, and the R is the equivalent resistance of all these three resistors. And this potential difference V can be given by individual current in each of these resistors as well. So here this V is equal to I1 R1. I1 is the current in resistor R1, and it is same as I2 R2 and I3 R3. But the current in the circuit is the sum of the current in these three branches. So if we put the value of current I in form of V and R, we get a relation between the equivalent resistance R and the individual resistances. So here 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Now if there are n resistors of same resistance R in parallel, then the equivalent resistance R is given by R by N. Let's check out two simple cases of two resistors. Case 1, if there are two resistors R1 and R2 in series, then equivalent resistance Re is given by R1 plus R2. In a special case, when R1 equal to R2 equal to R, then Re will be equal to 2R. Case 2, if there are two resistors R1 and R2 in parallel, then equivalent resistance Re is given by R1 cross R2 divided by R1 plus R2. And in a special case, when R1 equal to R2 is R, the equivalent resistance of that circuit will be R by 2. When current passes through a conductor or resistor, energy source like battery do work on charge to move around the circuit in form of current. This work done gets converted into heat, and that is known as heating effect of current. To move charge Q between 2 points of potential difference V, the work done is given by Q into V in joules, where Q is the charge and V is the potential difference between 2 points. The corresponding power of energy source like battery can be given by the rate of work done. So power P is the rate of work done, and W can be written as Q dot V divided by time. Q by T is equal to I. And now if we put V is equal to IR as per Ohm's law, you will get I square R. IR is equal to V, so this will be equivalent to V square by R. Energy supplied by the energy source is equal to power into time. So if you multiply these things with time, you will get the energy supplied. And that's all we have for today's session. I hope you would have enjoyed this. If you think you have learned something new today or this is useful for you, please click like button and subscribe us for similar type of videos. Thank you for watching. See you next time. Bye.